Hello there, so I'm back with the next pure data tutorial, and this one I decided to divide into 3 shorter videos because I sat down to record it and realized that it's more than 1.5 hours in total, and I believe no one deserves to sit through 1.5 hours of me mumbling and making Slavoj Žižek noises. So the first video is going to deal with our synthesizer we built the last time. I turn it into a polyphonic instrument and add mode wheel function to it and show you a bunch of new objects in the process. Then the next video is going to start dealing with sequencing. I'm going to show you how to use arrays, how to write and read to and from arrays, and we're going to create our first simple melodies. And then in the last video I'm going to show you how to output MIDI signals from pure data into other software, and I'm going to build a little drum machine that we can set with our MIDI keyboard or our MIDI controller. Alright, before moving on to sequencers, I would like to revisit our last project and make some adjustments. So I would like to make our little synth more playable and introduce a bunch of new objects that will be relevant to us in the future. And I start by getting rid of our strip node object and replacing it with a bunch of other objects which are going to perform the same task. And we're going to take the output for our node in object, our pitch and velocity, and combine it into a list of 2 elements. Now we can view this list by creating command 4. It's a symbol box. You can also find it in the put menu. It's just called list here. And now we can see our MIDI messages as lists. So we have node on and node off message. Okay. So again, the idea here is to have our line object triggered only when the velocity is non-zero. So let's get to that. First of all, we're going to create a trigger object for later, and we're going to put trigger list in it, and then we're going to store our pitch information in the called inlet of a float, and then we're going to bang our float object whenever our velocity is non-zero. So in order to do that, first we have to change the order of elements in our message, and we're going to do it with a message box. We're going to use variables here, and I actually find this pretty cool. We're going to apply the same logic as we have here with our DSP message. We're going to tell it that the second number in our list is going to be our first variable, and the first number in our list is going to be the second variable. So now we can test this, and as you can see, the order is reversed. Now we're going to unpack it, our list, and turn it into numbers again. Now we have our velocity here and our pitch in the right outlet. So now we're just going to copy this part because the logic here is exactly the same, and we want it to bang the float object only when the velocity is non-zero, right? So whenever this logic object outputs 1, we select 1, then it brings our float and we store our message in the float. So then we still have to send our velocity to our envelope, and for that we use another message box, and we just tell our message box we want to use only the second element of our list here. Now let's turn the DSP on and test it. It should work. Yeah, so it works just fine. Next thing, I would like to make something else with the line object. Let's say it not just goes down from 1000 Hertz every time, but it goes, let's say, up from -3 semitones, -2 semitones. So like it always goes one tone up when we trigger it. And in order to do that, we're going to use trigger float here. This is our goal, and now we have to create our starting point, which is also going to be a MIDI note, but one tone lower. Sorry, tighten it up a bit. Oh god. Push everything down a bit more. Then we have to back it. Now it should work. Now it's much more subtle, and we can adjust the length of the slide. No, this is weird. Let's do, I don't know, something like this. Now our slide is more pronounced, but not too much. Okay, now let's tidy this space up. We're going to put most of our patch here into a subpatch, and in order to do that we're going to create another object which is just called PD, and we're going to name it. It's going to be called synth, I guess. So now we have a subpatch, and here's the pop-up window of our subpatch. So we just select, let's say, everything from here on. We're going to leave DAC in the main patch. Then we're going to Command X and paste. So now we have this whole thing in our subpatch. Now we have to add some inlets and outlets to our subpatch to send things to it and receive things from it. So we're going to create inlet, and we're going to create outlet with a tilde because we're sending out signals. And what else can we do here? Let's add a volume control. Yeah, so let's change this to full volume in our subpatch, but we want to control volume with another thing outside in our main patch. So we're going to add multiply tilde to our synth. We're going to connect everything. Then we're going to add line. Let's add the message first. Let's say it's going to be short ramp time just to avoid clipping, but not much else. And now we're going to add a slider. It's a horizontal slider, and you type HSL into an object box, and here we have our slider. You can go into performance mode and move the slider around. If you add a number box, you can see it outputs numbers between 0 and 127, like a standard MIDI format. You can go to properties and do some adjustments. We're not gonna do it for now, but you can check out what you can change. For now, just really keep in mind that you really don't want your speakers to go to 127 because that would be really painful. So let's scale it by dividing 127 by 127. So now we have our slider output going from 0 to 1. And now we connect it to the line object. I have to make more space. And now yeah, everything works. The next thing, I would like to change our signal source to something more interesting. Instead of our oscillator, we're going to use a phasor. With tilde. Yeah, basically it also outputs a ramp, but continuously. It's like a V-line object, but it goes from 0 to 1 and then suddenly drops back to 0. And it does it in a loop, like an oscillator. So it's very useful for reading samples from the tables. We will talk about it. It's a really important object, actually. But for now, we're just going to use it as the sawtooth oscillator, because basically if you have a ramp going up from 0 to 1 and then dropping down, suddenly it's a sawtooth shape. So we can hear how it sounds now. It actually sounds pretty horrible on its own. I'm going to yeah, so maybe let's apply some filtering to it. VCF, so voltage controlled filter. The left outlet is the bandpass filter and the right outlet is the low pass filter. We're going to use the right outlet now. And now we're going to use our V-line object that generates envelope to generate the same kind of envelope for our VCF filter to demonstrate. So let's say multiply by 5000 and then add another 100 Hertz. Now it should work. I don't use it often. Okay, so kind of works, right? I don't know, I'm going to move stuff around a bit so it looks more aesthetically pleasing to whatever weird sense of aesthetics I have. Anyway, so now let's make this thing polyphonic. And in order to do that, we have to make an abstraction out of it. Abstractions are pure data patches that are loaded in the main pure data patch as an object. Let's see what I'm talking about. We're first going to create a new patch. Then we're going to Command A, Command C, select our synth subpatch and copy it into the new patch. We're going to save it in my workshop folder. We're going to call it synth 1. Now we close this, and now if we create a new object, we can type in synth 1, the name of our subpatch, and now it is in pure data as an object. Just keep in mind that you can reuse these abstractions in different projects, but you have to always specify the path to them. So here I just type synth 1 because it's in the same folder, but say if it was on my desktop. Yeah, let's move it. So now if you delete this and type synth 1 again, it doesn't work. So you have to, I'm not sure if it worked. Yeah, it's Option Command C to copy the path. Yeah, now it's copied, and now it doesn't work because we don't need the .pd. Yeah, so now it works again. Just keep that in mind. Anyway, so now it's back in our folder. I'm going to cut this out and connect this. And it works. Now, to make this polyphonic, we're going to use the poly object, which sorts out voices for you. It takes also pitch and the velocity, and then you tell it the number of voices and the voice stealing. The first one is the voice number. Let me show you. Sorry. So now the whole message is prepended by the voice number. As you can see, we have our pitch and velocity here, but then the first part of the message is the number of the voice. And yeah, to do the monophonic thing, we just need one voice, and yeah, let's do this for now. So, oh sorry, that's actually going to be 2 and 3, because we take the second and the third element of our list, and now it works. Yeah, now it works as it used to before, but if we want more than one voice, there is a really cool object called clone. It basically creates as many instances of an abstraction, so as many instances of our patch that we load in pure data as we want. We say clone 4 because that's the number of that's the number of voices we have currently. And now it created 4 instances of our synth patch. Now we just connect it to the poly object and it should work, I think. Oh yeah, well, it doesn't because we have to change it to 4 voices. And yeah, one last thing. In order to communicate with the clone object, we have to tell it to which instance of the abstraction we're referring to. So that's going to be our voice, but the problem here is that the voices here go from 1 to 4, but the numbers of the instances in clone go from 0 to 3, because the first instance is 0. And like there are few ways to do that. One would be just to add a -1 here. Yeah, so now we have it starting from 0, but the other would be add a flag here, I think. That's how it's supposed to look. So now it should. Yeah, so it actually works. The last thing I want to do is I want my mode wheel to control the filter envelope of our little synthesizer. So for MIDI notes, we have the note in object, but for control MIDI signals, like for knobs, we have the control in object. And now it should, yeah, understand what's coming out of my mode wheel. And again, as you can see, it has the same range as the slider. There is also a vertical slider. Yeah, so it works. And now we go into our clone subpatch and we add stuff to it. So we add another inlet and we say that we want to control the frequency range of our VCF, or at least the depth of the envelope. Let's say, again, let's divide it by 127 and then multiply it by, I don't know, 5,000. Let's just do this. Let's add a line object so we don't have any clicks here. Let's save it. We have to save it in order for all the instances to get updated with the new changes. And now here our clone object has the second inlet, and now we want to send our mode wheel information to every instance of this clone object, and we have to tell it to send it to all. And we use variable again, and now it should work. Yeah, it works. Basically, we control the depth of the envelope. We still have it go from whatever value is sent here. So we multiply whatever comes out of the envelope. So 1, it goes to 826 Hertz, then it goes to 50% of that, and then it goes to 0. So it goes to this plus 100 Hertz we have as our base frequency. And like if we crank it all the way up, it goes to 5000 Hertz first, then it goes to 50% of that, then it goes to 100. And yeah, one last thing I wanted to add was, let's make this light here be more or less prominent, and we add another variable instead of our ramp time here, and let's say it's going to be anything between, I don't know, 300 milliseconds and 10 milliseconds, something like that. I don't know, like pure data patches look messy, whatever you do with them. Or maybe I'm doing something wrong. Okay, so yeah, that's it, I guess.